All right, hello. Welcome to section 4.8. We are going a little bit out of order here. We skipped for 7, but we'll come back to it. That's going to be the quadratic formula. But we wanted to do a little bit about imaginary numbers before we get into that quadratic formula stuff. So section 4.8 technically it's called complex numbers, but basically it's about these imaginary numbers I. In this lesson, we're going to just talk about like what are imaginary numbers again, and then how do we add, subtract, multiply um, with imaginary, right? There'll be a separate lesson, part of tomorrow's lesson. We'll go over how to divide with imaginary. So in this lesson, we're just going to add, subtract, and multiply with imaginary numbers. Okay, so basically, hopefully you remember some of this, right? Like out of these ones, which are imaginary, right? They're the ones that basically have I in it, right? And again, we'll talk about what that I means in a little bit. And then in this lesson, we'll like add them, multiply them, and then later we'll work on how do we divide with imaginary numbers. Okay, so one more time with imaginary. Again, you might want to pause here if you remember what it is. You could pause and try and think through what is your definition of imaginary. All right, it's kind of a weird concept. Like mostly we have real numbers, but now we have these crazy imaginaries. And so kind of the idea is it involves square root. So back when we had like the square root of 36, basically that's asking number times itself. That'll give us 36. Okay, and there's actually two things that could go in that blank, 6 and also negative 6, because negative 6 times negative 6 is 36. Okay, so when you have a positive number underneath the radical, you can just get two answers, right? But the issue is then, well, what about if I wanted to root of negative 36? Okay, so basically we need number times itself that would equal negative 36, and 6 doesn't work, negative 6 doesn't work, and sometimes students want to say use one of each, but that's not how a square root works, is you have to have like the same number in these blanks. Okay, so what we end up saying is there's no real numbers that work here, and so this is where we get this idea of imaginary. Okay, so instead of being like plus or minus 6, this is technically plus or minus 6 imaginary. Okay, and so one of the ways to think of imaginary numbers is they allow us to do square roots of negative numbers, right? And it's just like you would think, like the square root of negative 9, right? The square root of regular 9 is plus or minus 3. So this one's just plus or minus 3i. Okay, and so just to be very, very specific here, what's happening is if we break this square root into two things that multiply to negative 9, the square root of 9 is the 3, and the square root of negative 1 is the I. Okay, so if you don't already have this down in your notes, you might want to jot down one more time what I is, and I just stands for the square root of negative 1. Okay, and then in this lesson, it's going to come up. This is another real important thing to have down is I squared would basically be, so here's I, and then if we square that, that's just going to be negative 1. The square and the square root cancel out, so that I squared is negative 1. And this little fact you're going to use a bunch in this lesson. So hopefully you've got these two things down in your notes. Okay, and one other quick note here. I is not like x. So in math, like when we have 3x, that stands for like 3 times some unknown amount. Not true with I. I stands for specifically the square root of negative 1. So this could actually be thought of as 3 times the square root of negative 1 would be a way to think of it. Right? So I is a specific number like pi, not a variable. Okay, so one more time with simplifying. Pause the video and see if you can remember how to simplify these radicals. So basically, this is where I comes up, is you have negative square roots. So see if you remember this simplified process. Okay, so the one on the left, if we just break up the two things that multiply to negative 49 would be 49 and negative 1. And then basically square root of 49 is 7. Square root of negative 1 is I. Okay, and if you had a plus minus in front there, that's great, but I'm not going to worry too much about that for this particular lesson. All right, so second one, I can break off the 40 and the negative 1 to get us the I, but then also this 40, it's not a perfect square this time, So we want to do that trick where we want to break the 40 part into a perfect square and a non-perfect. So I think for 40, the only one that's going to work is 4, right? So 4 and 10. Again, make your list of perfect squares if you need it, right? Blah, 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 blah. But I think the one that's going to work here is 4. So this gives us 2 square root of 10 with an I. Okay, and oftentimes they're going to write the square root part at the end. So they're going to put the I there. Otherwise, it looks like the I becomes underneath that radical, which is not what we want. So oftentimes they'll write 2I and then radical 10 like this. Okay. So I guess a form of imaginary, or these are sometimes called complex numbers because they have both a real part and an imaginary part. So I don't know if you want to jot this down or not, but this is, I guess, technically it's called a complex. I should probably say this is complex. And a complex number consists of two parts, a real part and an imaginary. All right, so add, subtract them. I bet you could almost just figure this out. So see, if you want to pause the video and see if you can actually add or subtract these without any help from the teacher, that'd be great. Then unpause to see the answer. Okay, so much like the directions say, when you add or subtract, you just combine the real and imaginary parts separately. So here, I'm just going to do the the positive 7 plus negative 3 to get 4. And then I'm going to do the I parts, negative 2I plus I. So it'd be negative I. So my answer is 4 minus I. Okay, so basically just combine your real parts, combine your imaginary parts, and you're done. All right. With subtraction, same thing. Just be careful. I have to do 8 minus 8. Those are the real parts, and then the imaginary parts. I've got to do 6I minus negative 6I. Okay, so as you might expect, this becomes a plus down here. It becomes plus 6I, so 12I, and then this is just 0. So our answer here would be 0 plus 12I, and oftentimes they're not going to just even write the 0 part. They're just going to write it as 12I. Okay, so when you add or subtract, you basically just combine like terms is another way to think of it. Combine your i's through addition or subtraction. Combine your non-I part through addition or subtraction. Okay, so a couple more just to make sure you got it. Pause the video, try them in your notes, and then unpause to watch. All right, main thing I guess just for subtraction, be careful. It's 1 minus 3, and then 5I minus negative 2I. Okay, so we get negative 2 here, and this would be 7I. You add those together, you get 7I. So our answer here is negative 2 plus 7I. All right, and to add one, we're just going to combine the real parts, so that's 0, and then combine the imaginary parts and just adding those together, so that would be 18I. Right, and again, if you want to drop the 0 there and just write it as 18I, that would work too. All right, let's do some multiplying ones. And again, I shouldn't even put the directions on here because I'm guessing you could just figure it out. Yeah, so if you want to pause the video and try this, that'd be great. Otherwise, keep watching. All right, so first thing is to know that when you do I times I, that gives you I squared. And we talked about earlier, that actually stands for negative 1. So anytime you get I squared, you can replace it with a negative 1. All right, and again, remember, that's because I is the square root of negative 1. And if we square that, that just becomes negative 1. All right, so here we go. So I want to distribute this in just like you'd normally think. So that's going to be minus 15 times I, kind of like 3x times negative 5. And in the back, I would have 3I times 2I. So that's going to be 6I squared. Okay, and here's where our trick. So I squared is now negative 1. So we can simplify this a little bit further by taking the I squared and replacing it with a negative 1. Okay, so the back part becomes 6 times negative 1. So we have minus 15I then minus 6. Okay, with two binomials, it's just that FOIL process, which you've done before. So, whoa, sorry, my pen got out of control there. 2 times 4, 2 times 5i would be 10i. Negative 3i times 4, negative 12i. And then negative 3i times 5i. Sorry, that's kind of messy there, but that's going to be negative 15 with I squared. All right, and then we're just going to clean this up some. So these are like terms, 10i minus 12i, so that's like negative 2i. And then this would become negative 1. So in the back here, we're going to have subtract 15 times negative 1, because I squared is negative 1. So that becomes 15. And then combine the 8 and the 15 to get 23. And then we have minus 2i. All right, and so on a multiply, you just got to FOIL and then clean it up a bunch. So our final answer, sorry I have a hard time circling stuff, but that's our final answer. All right, 2 more for you to try. So pause the video and give these a shot. This will be a good test to see if you got the multiply process down. All right, so here we go. So multiply 7i and 3i, that's going to be 21i squared. And then again, anytime you have I squared, that's negative 1. So this is like 21 times negative 1. Negative 21 is our final answer. Okay, next one, again, we're just going to FOIL. So 4 times 4 would be 16. 4 times negative 5i would be negative 20i. 5i times 4 is positive 20i. And then 5i times negative 5i would be negative 25i squared. Okay, and so this one's kind of interesting where these actually combine to 0. Negative 20 plus positive 20. So then we have 16, and then we're going to end up with a plus 25 because we're going to have negative 25 times negative 1 for I squared. So that becomes plus 25. So it all cleans up to 41. Okay, and then in the next lesson, we're actually going to learn about this. This is called the conjugates, one of my favorite math words. I'd like to maybe name a child conjugate or something. That's, I think, a good math name. But they're just this, everything's the same except one's a plus, one's a minus. And when that happens, like the middle parts cancel out, which is kind of magical. And so you have this weird, crazy expression that simplifies all the way down to 41, which is actually pretty magical. Okay, and that'll happen anytime you have like a plus bi times a minus bi. So everything's the same except one's a plus, one's a minus, and that's called conjugates. And we'll get into that a little bit in the next lesson. All right, that is all. Thank you for watching.